Hi everyone, welcome to Dot Point S3, and this is again on soils and sustainability. But in particular, this is a bit of a follow-on from the last Dot Points S1 and S2. So those were looking at physical and chemical aspects of soil, and this is basically testing those things. So it might be a bit brief, but it's the tests that we did in class, and it's important that you do these tests, or at least look up people doing them on YouTube so you understand how they're done, because the past HSC questions coming up later will expect that you've done them. So the first one we didn't test everything, but we did pH, and we got different results here depending on what soil you were testing. But basically you take the teaspoon of soil, just follow the instructions here. You need to put on the universal indicator, the barium sulfate powder, measure the pH, and you got a different pH depending on the soil. I don't need to go into what these mean for plant production because we've already done that in the last video. Physical characteristics, again, you need to break the soil down into parts and look at which one it fits on this diagram, and we got different results depending on what the soil was that you were testing. These were the results for one class. If you want to look at what this means for plant production and how you can change it, you need to look at the previous S1, S2 video. Soil texture. So to test soil texture, you need to take a small sample and make a bolus, or a small ball about the size of that fits in your palm. It's about the size of a golf ball. Basically, you just take a little bit of soil and add a little bit of water to it, as increasing amount of water until it becomes kind of the consistency of like Play-Doh kind of consistency, and then you need to stretch it out into what's called a ribbon. And if the ribbon breaks apart really easily, it's going to be higher in sand, and if it pushes out longer, it's going to be higher in clay. And you can see here ribbon length. So as the ribbon gets longer, it's going to get higher and higher in clay and lower in sand. And so this is going to tell you, if you're trying to work out what the soil type is, you can work out firstly how long the ribbon is that it makes, but then also what it feels like. And you can see here, for example, slight coherence sticking when wet, many sand grains you can still feel. Very coherent bolus, very smooth to silky when manipulated. So you're not feeling sand anymore. So it's starting to be kind of a silty loam rather than any sand in it. And you can work out the texture. You should be able to, at the end, work out the texture and name your soil according to one of these here. And you'll get different results depending on which soil you do. The porosity, as mentioned before in the S1, S2, this is the amount of area that is not soil. If you take a sample of soil and of a known volume, and you then fill it up with water to the top, that water will fill up all the air, or all the space, or all the pores in that sample. And that's basically measuring the amount of not soil in that area, the bits that aren't soil. And so the way that you then work that out is the porosity is the amount of water added to the sample divided by the total volume of the sample, and then you times it by 100, and so you'll get a different answer. These are quite high because we didn't do it as well as we could have. We ideally need to do it by taking a perfect sample from where it is in the field, but we had to kind of put bits and pieces together, so we would have changed the pore size. So these 41, 43 is very high. It should probably be closer to in the 20s mostly, so, or even lower. Bulk density, the last one here in physical. So we have a core taken here, and this metal core is of a known volume. We know how much is in there, and so we then need to dry that soil out and weigh it, and it tells us how dense or how much soil weight there is actually in that area. And so the bulk density in grams per cubic centimeter is the weight of this dry soil. This is the key thing here. You need to dry it in an incubator around 50 degrees. You'll remember from a previous HSC question, if you're putting it in an oven at 400 degrees, that's to burn off the organic matter. It's not to do with density. But you put it in an incubator around 50 degrees, dry the soil out, weigh it, and then you divide that by the volume of the core, of this core here, and that gives you your bulk density. And you should show working, of course, because in the HSC exam, you need to show working if there is any maths questions. Some of these questions you'll have already seen. They're a bit of kind of overlap from S1, S2 dot points. So a student carried out the following procedure on a sample of dry soil, weighed the soil, heated the sample at high temperature, 400 degrees, and reweighed the sample, and that's testing organic matter content. As I mentioned before, that temperature, high temperature, is going to burn off organic matter. This question here, what's being determined by this test? Again, you're squeezing out a ribbon and a bolus here is being created. So the answer is texture. This one here, we have the graph shows the availability of nitrogen to plants growing in a soil. The soil was tested and the pH is shown here, X for tons of material required to alter the soil pH. Gypsum, 5 tons, 0.3 change. Lime, 3, 1 change. 0.3 tons, 1 pH unit change, and 10 tons of mulch changes, 0.2. The best strategy to make nitrogen more available to plants growing in this soil is to apply which thing. So we need to increase the pH. It needs to get closer to 6 to 7, which is the ideal range. Nitrogen availability up here at least 6 here, 6 to 7. So to do that, we can change the pH to make the pH closer this way by adding lime. However, if we put nitrate fertilizer on, you might think, well, nitrogen becomes more accessible, but if we put nitrogen on, remember fertilizer is acidic. So fertilizer is actually going to change the pH 1 unit this way, not this way. So it's actually going to make the problem worse, and it'll make it more acidic. There'll be more nitrogen on there, but it'll be so acidic that the plant actually won't be able to get access to that nitrogen. So the answer here is lime. Lime is the best one. And describe the effect of organic matter on a physical characteristic. I've mentioned that in S1, S2, I've answered it, so you can check there. Explain how soil texture influences water holding capacity. I also answered that on S1, S2, which you can check there as well. Soil to test, determine the pH of soil was 4. What does this pH level indicate? If you raise the pH to closer to 6 or 7, plants can access it better, access the nutrients. What is most likely the result of a loss of soil organic matter from soil over time? It gets a breakdown of the soil structure. Number 16, which of the following is a key feature of a soil with high bulk density? You're going to have closely packed soil particles. And lastly, or the next one, which characteristic of a soil would give the best indication of its chemical fertility? It is ion exchange capacity is direct measurement of the chemical fertility of a soil. Acidity is indirect thing that might cause a change in the ability of plants to access it, but not the fertility of the soil itself. Which term is used to describe the arrangement of soil particles or particles in a soil? That is structure. Which of the following statements correctly relates chemical characteristic to an effect that increases plant growth? Soil particles with high CEC release large numbers of cations. This is chemical. CEC, cation exchange capacity, is chemical. Extreme pH. pH is also chemical, make all plant nutrients not more available. That's not necessarily true. That's actually the opposite to true. A low bulk density value, and bulk density remember is physical, so it's not chemical. And soil particles with net positive charge attract cations. It doesn't relate to how it improves plant growth. And the last one, which of the following describes only physical characteristics? Again, as we mentioned in S1, S2 dot point, porosity, structure, texture are all physical. Nitrogen status is chemical, and ion exchange capacity is chemical. So the only one with physical in it is this one, porosity, structure, and texture, which is A.